Hello viewers, today we are trying to look at De Morgan's law, that is mathematics. So before we proceed, before we start solving questions, if it's your first time coming across our YouTube channel, try to subscribe, comment on the video, share with your friends for more videos. So today we are going to concentrate on what we call De Morgan's law, and probably under De Morgan's law there are certain things that we have to understand the most. Mostly we need to know how to change a symbol from a symbol to a word. We need to understand that union, which is a symbol union, moves or changes to a word or. Alright? We also have intersection, which changes to a word, and then probably we also have a member of, which mostly changes to not a member of. I'll write not a member of inside the brackets. Not a member of. Okay. Now, if we critically think of what De Morgan's law is all about, definitely we only have two types of De Morgan's laws. We only have two types of De Morgan's laws. We understand to say, suppose you've been given two different sets. You've been given two different sets. What are you supposed to do for you to understand critically what De Morgan's law is? If you have been given two sets, let's say set A and B. If you want to express these two sets using De Morgan's law, what you are going to understand is we are going to have something like this. Union B, complement outside, it has to be equal to A, complement, intersection, B, complement. That's what De Morgan's law is all about, meaning that distributing this complement on these two sets is just one and the same, like changing the sign in the middle. That is the first type of De Morgan's law. The second type of De Morgan's law has to be like this, whereby we are having intersection in between. You put a complement outside. So the moment I distribute this complement on these two sets, the sign in the middle is going to change. We are going to have A, complement, union, B, complement. Now, how do you change? How do you handle this type of equation? Suppose they give you to say, prove De Morgan's law. You've been given this or that one. What are the steps you are likely to take whenever you want to solve questions under De Morgan's law? We'll try to solve an example. If an example has come like this, they are saying prove De Morgan's law, then they write something like A union B complement, which is equal to A complement intersection B complement. 5 marks. What are you supposed to do for you to understand this same question? So we have certain steps that we should be able to notice. We have a lot of steps that we should be able to notice. And what are those steps? Let me try to give you a simple example first of all. If myself, I'm part of set A, I'm found here. This is a person. If myself, I'm located in set A, do you think I'm going to be part of set A complement? No, that can't happen. That's what mostly we normally do under De Morgan's law. If myself, let's say maybe I'm X, I'm part of set A, this actually means that I can't be part of set A complement. Reason being, I'm already located in set A. That's what we are going to be doing under De Morgan's law. And what you should be able to understand here is this. De Morgan's law involves solving on both sides. We move from left hand side going to the right hand side. But what are some of the things that we should be able to write before you even solve the entire question? What we should be able to do is, here, if we are starting from the left hand side going to the right hand side, first of all, you need to write a statement on top to say we need to show that this set is subset of that other set. So I'll say we have to show that A union B complement is a subset of A complement intersection B complement, meaning that you are moving from the left hand side to the right hand side. So here what I'm going to do, I'll say we move from left hand side going to the right hand side. So if we are moving like that, what are you supposed to do next now? Suppose you are moving like that, meaning that I'm going to start with this to get what is here. And you have to know how to change the symbol, or rather the sign, to a word. So I'll say let this set, which is A union B complement, let X be a member of that given set. If X is a member of this set, then X cannot be a member of A union B. So probably here, if you know how to change the words or how to change the signs to words, you should be able to know also how to expand, how to factorize. So probably here we are going to use expansion. Expansion has to work. We are going to be using also two things. One, expansion, how to expand. The second one has to be factorization. How to factorize. All right, we proceed. Okay, so here I'm going to expand this together with what is inside. So probably the moment you remove the brackets, this is where now the symbol changes to a word. This one, remember we are saying union moves with O, meaning that if set X is not a member of A, it can't be also a member of set B. Now, what does it mean? If X is not a member of this, or it can't be a member of this, meaning that X is going to be a member of A complement, and X can also be a member of B complement. Why am I using the word and? It's because it can't be found in set A and set B, meaning that it can either be located in set this and set that. All right. So we proceed. If you have seen something like this, how do you combine? Definitely this has to change now. The word is going to change to a symbol. The word has to change to a symbol. How do you change a word to a symbol? Probably we said intersection goes with and. So meaning that what I'm going to do is this. I'll take this and that, where there is and, I'm going to replace with the symbol. So we are going to have X be a member of A complement intersection X be a member of B complement. Then what are you supposed to do? We started with expansion. Now we are coming to factorization. You factor out what is common. So here you find that this is the thing which is common, including that one. I'm going to write them here. X be a member of A complement intersection B complement. Probably the moment you reach at this given point, what are you supposed to do and what are you supposed to understand? You are going to tell them to say this shows that A union B complement is a subset of A complement intersection B complement. And this has to be your first expression. So you need now to prove from the other side going to the other side. And how do you prove? Moving from the other side going to the other side. It's very simple. Let me try to handle it. I'm going to start from a new page for your easy understanding. Alright, so remember we are still on De Morgan's law. We proceed. We are still on De Morgan's law, but now we are going to move from the right hand side going to the left hand side, because I was proving from the left hand side going to my right hand side. Still, I'm going to write the statement. We need to show that. So here, since we are moving from the right hand side going to the left hand side, what are you supposed to do? I'll say A complement intersection B complement has to be a subset of A union B. I'll put this inside the brackets and I'll say complement. Which part to which part are you moving? Now we are moving from the right hand side going to the left hand side. All right, we proceed. So what you are going to understand probably is we are trying to prove from the right hand side to the left hand side, meaning that I'm going to deal with this. But remember here, since this doesn't have any brackets, you have to go direct without even wasting time whereby you're saying let x be a member of blah blah blah. No. So here what we are going to do, I'll say yes, probably I'm going to say let x be a member of A complement intersection B complement, right? So what I said is here, this thing has already been removed from the brackets. What are you supposed to do now is to expand this together with that. Then this has to change from a symbol to a word. And how do you change from a symbol to a word? What we are going to do is x will definitely be a member of A complement, and x can also be a member of B complement. If x is a member of A or B, what are you going to understand? Meaning that x can't be a member of A, or it can't be a member of B. Why? Because it is already located in either this and that. We proceed. So from here, what you'll be able to understand is this. We are going to change this one. How are we going to change this? How are we going to change? To change this, the word which is in the middle, we are going to turn it into a symbol. And how do you change? We are going to say x cannot be a member of A union x cannot be a member of B. So probably I'm going to factor what is common here by putting the remaining things inside the brackets. So meaning that this is the thing which is common, and also that one is the thing which is common. We are going to have x can't be a member of, open bracket, I'll say A union B. I'll put like this. If x can't be a member of that, what does it mean? What does it mean? This actually means x can be a member of, open bracket, A union B close complement. Meaning that whenever you are proving from the right hand side going to the left hand side, probably if you check from here, I'm trying to move from this given side to the left hand side. Meaning that whenever I'm proving this, I'm able to get this. That's what I'm from doing for this whole process. This is what we call De Morgan's law. So they can either change the sign in the middle on the left hand side. They can use intersection. Here they will use union. The process is the same. Keep on waiting for more videos. Let me try to drop a question that you can solve down here at your free time. You can also say prove De Morgan's law. Then I'm going to write it like this. A intersection B complement has to be equal to A complement union B complement. Thank you for watching. Share the video for more to your friends.